Hello everyone. Today I will be presenting my project titled Smart Fitness Tracker Data Analysis. This project focuses on analyzing fitness tracker data such as activity, sleep, calories, and BMI to understand user behavior and extract meaningful business insights. So our project overview is this project analyzes smart fitness tracker data. Okay. And the goal of the project was to analyze smart fitness tracker data similar to platforms like Strava or Fitbit. The object was to identify patterns in how users interact with fitness tracking features and understand relationship between activity level, sleep pattern, and health metrics. The analysis was performed at the daily level, which allows us to observe trends in user behavior without the complexity of minute level or hourly level datasets. So our business objective is understand how user engage with fitness tracking features, identify behavior patterns across activity, sleep, and health metrics, support data-driven marketing and personalization strategies. So we have used datasets. Only data level datasets were used to ensure consistency and business relevance. So among 11 to 12 datasets, we have selected these five files which are final for our data evaluation and validation. So first is daily activity merged CSV file, which is the base data sets, which is the main data set which we'll be using, which involves columns like steps, distance, calories, intensities. And daily calories, second is daily calories merged CSV file, which contain daily calorie burn. Third is daily steps count, which contain the data of daily step. Then fourth is sleep day merged file, which contains sleep duration and sleep efficiency. The fifth is weight log info, which contains weight and BMI information. And very few data is present here. That's why it is written sparse data, tiny data sets. So we have excluded these data sets, hourly data, hourly minute, heart rate, second merge.csv, which because it is of no use already the data present in these data sets are present in these. So we have selected the five sets. Now we will be performing our all the operation like data cleaning, data validation, data preparing, handling all the errors and removing all the null values, empty columns. We'll be performing on these five data sets. So first operation comes data cleaning and preparation, which include like converting date columns to proper datetime formats. Okay, the first we have our data in the date column in the object format or text format, which is manually written. So we have to convert it into datetime formats. Second, removed duplicate sleep records so that our primary key can be implemented there and no duplicacy occurs. Third is handle null values nullification using business aware strategies like awareness of the business objective so that our data cannot be lost by directly removing the null values. Then for the sleep data CSV file, missing values retained indicates non-usage of sleep tracking, which is of no use. We have removed them, retained them. Sorry. Then BMI versus or weight data. So sparse column removes, that is tiny column which were of no use. Then BMI used only where available. No artificial imputation was performed to avoid biases. Okay. Then analytical data frames created. So by merging as per the business objective, we have merged our five sets into three data frames which we'll be using for final our SQL queries and the Power BI dashboard. So instead of merging all the data sets into one table, three purpose-driven data frames were created. First, which contain daily activity. In this, core activity and calorie analysis, which daily step versus calories, activity intensity patterns, and user activity segmentation. Second is sleep day, which contains lifestyle and engagement analysis, sleep tracking behavior, sleep versus activity consistency, and user engagement insight. Third is body metrics, which contain health outcome analysis, BMI versus activity level, BMI versus calorie expenditure. This modular approach reduces sparsity and improves interpretability. Okay, so we will be using the data sets. Now, in the Python file itself, we have performed few data visualization. So first is how does daily activity impact calories burn? So here we have created these two charts. First is of steps versus calories burned. Second is of active minutes versus calories. Okay, let me zoom it so it's clearly visible. Yeah. Hmm. So here the calories which should be burned per day, and this were the steps count. This is the total active minutes of user. Second is her user who tracked sleep more consistent in daily activity. So we have box plot here. Are the total steps. Okay. Third, can user, this is our second chart. Third chart is, can users be segmented into behavioral groups based on activity, sleep, and BMI? Okay. So highly active users, moderately active user, and sedentary active users. So this is the BMI average value between 27, 28, I guess. 28 is 27 point something will be the BMI averages. Then finally, after this, we have imported our datasets into MySQL. Okay. Then all the three datasets, daily activity CSV, sleep day, body weight. So the clean fitness tracker dataset were imported into MySQL to perform structured data storage, normalization, and analytical query. The CSV files that were previously cleaned and prepared using Python in the Jupyter notebook were loaded into MySQL tables using the MySQL Workbench import wizard. Okay. And a common user table was created, user identifier, which a user ID column was created and set as a primary key and is linked to across multiple tables such as daily activity, sleep records, and body metrics. All the three tables, the user ID was linked and is auto incremented also. So we created three tables in MySQL. Daily activity, we imported the three tables, daily activity, sleep day, and body metrics. We perform operations in them, and there also we check for the null values, duplicacy, and then updated the all the columns like activity dates was set as primary key. Here also it was set as primary key, and here metric ID in body metrics data table. It is also set as a primary key, and the user ID was also created and set as a foreign key there to link from the users table. Okay. After performing all the queries in SQL, we have imported into the Power BI using the ODBC connector. Okay. So Power BI visualization capabilities, multiple dashboards were developed to analyze different aspects of user behavior. So we have created there four dashboards. First is for user activity dashboard, that is user engagement, which focuses on physical activity patterns such as steps taken, calories burned, and active minutes. Second, the sleep analysis dashboard examines sleep duration, sleep efficiency, and variations in sleeping patterns. Third, the body metrics dashboard analysis weight trends and BMI distribution to understand overall health indicators. Fourth, finally, an insight and business recommendation dashboard was created that summarizes key findings from the analysis and provides data-driven recommendation for improving user engagement and promoting healthier lifestyles habit. The use of Power BI enables stakeholders to quickly interpret complex datasets and supports informed decision making through visual analytics. So here are our dashboards. This is our first dashboard, that is user engagement. Here is the list of all the users. By clicking one each user, we can see their activity, like what is the daily step, trend, then percentage of activity, this user spending, activity time. Okay, what is the average steps? What is the total steps? What is the average calorie burn? Okay. Second dashboard is for sleeping pattern of users. Okay. So this is average time in bed, sleep gap, extra awake time by the users. Okay. Percentage of poor, normal or long sleep. How is the sleep of user? Then sleep trend over time, day. This is starting from zero till starting from the 0th day to the 30th day, last day of per month. Okay. Third dashboard is for body metrics weight, which which we can see here from selecting particular user. Okay, this is the average data we can see here. So there are 8 total users, which is max weight is this, average BMI is 25.18, average weight is 72, and minimum weight is 52. So the max weight is 133. One of the user is 133.5 kg, and the one of user has a minimum weight of 52.6. Okay. Then the last final dashboard is of insights and business recommendation. This is our insight which we have seen from our data set. This is our recommendation that we recommend for their better health. Like introduce personalized notification, encouraging user with low daily steps, uh, receiving 2 to 3 notification per day to encourage them to burn more calories and to complete the total number of steps which is set by the user per day, like 10,000 steps per day. And providing sleep insights, bedtime reminders, sleep improvement tips for user with irregular sleep patterns. And use activity, sleep, and BMI data to offer customized fitness programs and wellness recommendations. Yeah. Yeah. So summary in which we have analyzed is higher steps and active minutes are strongly associated with higher calorie burn. Sleep duration alone does not show a strong linear relationship with activity levels. BMI data is sparse but shows variation across activity segments. We do not have much data, BMI data, which is tiny. We have in our data set, but it shows variation across activity segments. We have a clear vision how a user is active and involved in their activities. Users can be meaningfully segmented into sedentary, moderately active, and highly active groups. Okay. Users who track sleep trend to be more consistent activity. So business recommendation, these are to promote sleep tracking as a part of holistic fitness experience, target sedentary user with motivational nudges and challenges, and user behavior based segmentation for personalized marketing campaigns. So firstly, we have used Python language in the Jupyter notebook for data cleaning and visualization also, and retaining the null values and cleaning the data sets. Also, we have 5 data sets which were selected from multiple data sets and created into 3 data frames, which is performed further for operations. Then we loaded our tables into the MySQL Workbench. We perform queries and merge the data and set foreign key and relationship between the tables. Then we have connected our MySQL to Power BI using ODBC connector. There we created dashboards which was directly linked to our datasets. In libraries in Python, we have used Pandas, Matplotlib, and Seaborn. So yes, this was our project. These are our data dashboards, and we have completed our business objective and has recommended the what all the user can do, what all the fitness tracker app can do to the user to track more data and focus on health of the user. So thank you.